So, writing the equations that we're concerned with, which is equation 4b, and that equation looks like this. Okay, it's just a displacement. So I'll write that down here. xf minus x initial, that's the displacement in the x direction, equals to it. We can always go back. We don't have to tie ourselves. We've already derived it. It equals to the average velocity times time. So the average velocity is our initial velocity in the x direction plus the final velocity in the x direction divided by 2. That's the average. And we're going to multiply this times time. Now, we want to get rid of our final velocity here. And how are we going to get rid of our final velocity? Well, we're going to use equation number 5. In other words, let's say that we know our initial velocity, we know the acceleration in the x direction, which is constant, and we know the time. So let's go ahead and bring this over here. We're going to take our initial velocity, no, our final velocity in the x direction. It equals to the initial velocity in the x direction plus constant acceleration plus the product of constant acceleration in the x direction and time. So what am I saying to you? I am saying this. I'm saying that we're going to take this left-hand side. I'm going to substitute it into this equation right here. Because we know our initial velocity, we know our acceleration, and we know our time. Okay? So I could say that for all of them, but you know that this is still just the same initial velocity, and this is the same time. Okay? So let's go ahead and do that substitution. We end up with xf minus x initial equals to the initial velocity in the x direction plus the acceleration in the x direction times t all over 2. Now what do? Well, we need to group our initial velocity, and then we're going to distribute our time. But let's focus on grouping first. So this is 2v initial x times t plus a sub x times t, and that entire quantity times t divided by 2. So let's do our distributive property here. We're going to multiply t times this quantity and t times this quantity. So we get 2 v initial in the x direction times t plus a sub x times t squared all over 2. Okay? And this is just going to equal to v initial in the x direction times t plus 1/2 a x times t squared. So what does our final equation look like? Looks like this. xf minus x initial equals to v naught x times t plus 1/2 a sub x times t squared. This is going to be equation number 6. Okay. Equation number 6. Okay, let's go ahead and write equation number 7. And equation number 7 is going to be tied so much to this. If we consider, instead of our balls moving horizontally, that they'll move vertically. Okay, and we have some initial y here, and some final y, and some initial t, and some final t, as well as some initial velocity and some final velocity in the y direction. Okay, we can write a similar equation. And that similar equation looks like this. YF minus y initial equals to the initial velocity in the y direction times t plus 1/2 a y t squared. This is going to be equation number 7. We could also do the same thing with z, but we don't need z. In the next video, I'll actually extend these, and I'm going to extend them to include the, what do you call it, trigonometric functions.